Lesson 2, Permission to Come Aboard. Welcome aboard the New Horizon. Here you will learn more about your ocean voyage to the Great Pacific Garbage Patch and how AI and robotics might help the voyage as well as in your own community. Today, you're going to be able to define the words algorithm, computer program, and pseudocode. You're going to be able to understand how computer programs use algorithms and the pre-writing process known as pseudocode. You start your voyage in the docks. In the last lesson, you saw how busy everybody is at the docks preparing for the ocean voyage. We have all sorts of heavy equipment and luggage that needs to be sorted and put away. You also saw an example of some robots and some of the tasks they might perform to help make our lives easier by moving heavy items around. Then, you thought about a few ways that robots might help you in your own life or community, and you sketched out some innovative ideas. Throughout these artificial intelligence and robotics lessons, you are going to follow along with the New Horizon voyage to the Great Pacific Garbage Patch. You're going to meet interesting scientists along the way, and you're going to learn how AI and robotics might play a role in helping those scientists complete tasks more efficiently, as well as thinking about ways that AI and robotics can help you in your everyday life. How do you think robots know how to complete their tasks? Is it magic? Do robots just guess? Or do robots follow a computer program? Robots follow computer programs. A human writes instructions or algorithms, and the robot follows those instructions. All robots need some sort of program that is written by humans in order to do anything. Computer programs are simply a set of instructions or a plan that you give to the robot. These instructions go in a step-by-step order, step 1, step 2, and step 3. But these instructions can also include looping or questions to make sure that robots are doing the right things. The basic building block of a computer program are algorithms. Algorithms are a set of these step-by-step instructions to complete a specific task. A computer program can have many algorithms inside of one single program. Let's watch the following video and learn more about algorithms.
You may have heard the term algorithm recently, whether it was online or maybe in some conversation about technology. It's a word that gets thrown around a lot, but what exactly does it mean? Well, simply put, an algorithm is a set of steps used to complete a specific task. They're the building blocks for programming, and they allow things like computers, smartphones, and websites to function and make decisions. But in addition to being used by technology, a lot of things we do on a daily basis are also similar to algorithms. Let's say you want to make some spaghetti. In order to do this successfully, there's a certain set of steps you need to follow in a particular order. First, you need to boil a pot of water. Once it's boiling, you then add the spaghetti and cook it for a set amount of time, stirring occasionally. Once it's finished, you drain the water and then it's ready to be served with a sauce of your choice. That entire process is actually an algorithm. Because you followed those steps in that order, you reached your desired outcome, a delicious pasta dish. But if you were to make a mistake, say over or undercooking your noodles, it probably wouldn't be as good. Programs work in a similar way. Their code is made up of algorithms telling them what to do. Let's say that we want to use a navigation app to get directions. When we punch in a destination, the app uses an algorithm to look at the various available routes. Next, it uses a different algorithm to check the current traffic. And then a third one takes that information and calculates the best available route. All of these algorithms are built right into the app's code. If there were any kind of error in that code, the app wouldn't be able to follow these algorithms correctly, meaning you wouldn't receive your directions. Both of these examples show how both humans and computers can use algorithms to perform everyday tasks. The difference is that computers can use algorithms and calculate things better, faster, and more efficiently than we can. Technology is only going to continue to evolve and get even better at what it does. As long as coding and programming continue to be used, algorithms will be at the heart of these technologies, guiding what they do and how they do it.
Let's practice with algorithms. We need help moving some heavy boxes onto the New Horizon. Let's look at this robot by clicking the green flag and see what the robot will do. So what's happening? What happens when the robot reaches the box? Well, notice the moment the robot reaches the box, it seems to go back to its original starting point. Now, let's look inside of the robot's code and see what algorithm is controlling the robot. Now we are inside of the robot and looking at its computer programming. Take a look at this code. These code blocks represent the algorithm controlling the robot animation we saw. Even for a simple program to make a robot move forward to the boxes, we have to use several steps. Let's pull out these blocks in smaller groups to see what is happening. The first block we have is the when green flag clicked. This allows the program to start whenever we click that green flag. It'll start running through the code that is below it. Next, we see that all of the code is enclosed inside a forever block, also known as a loop in programming. This forever block means the code will continue to run in sequence from top to bottom until we click the red stop sign. So now we know everything inside this forever block will loop forever until we press the stop button. So what's inside this forever block? Well, the next set of blocks, this repeat until, tells the robot how and when to move. The robot should move 100 steps until it reaches the color of the crate, until it's touching that brown color. This is also known as a conditional statement in programming, which allows instructions to run until a certain condition is met. In this case, the condition is touching the boxes represented by the tan color. Every time it moves 100 steps, it's going to wait for a second and then look and see, am I touching the box? No? Then I'm going to move 100 steps again. But what happens when the robot is touching the brown colored box? Well, we stop repeating. Repeat until we touch that color. So when we stop repeating, we go to the next set of instructions in our forever loop. These instructions, the last two blocks in the program, say go to x equals -177 and y equals -31, and then wait 1 second. This tells the robot to return to its original position on the screen. You can think of your screen as a coordinate plane. Imagine graphing coordinates in math, and any single location on your screen is represented by a specific x and y value. In the current program, the x and y correspond to the location the robot starts at. If we want to run our program on a loop and we want the robot to reset at the end of the program, we have to tell the robot to go back to that starting location. What would you think would happen if you didn't tell the robot to reset? Where do you think it would go? In this course, you will get a chance to explore even more by writing your own programs. So to illustrate this repeat until block, let's change the color to something like green, which the robot is not going to ever touch because it's not in our program. What's going to happen to the robot? Well, let's see. The robot continues to move all the way to the end of the screen. And why does that happen? Because we've told it to move 100 steps until it sees the color green. But it's never going to touch the color green, so it's only going to keep moving forever and ever. But when we return it back to the color of the box, then it'll return back to its original position. What if we changed the starting position of the robot? So after it touches the color of the box, we want it to actually go somewhere else. So let's try that. Instead of y equals -31, let's do y equals +31 and see what that changes. Now we see our robot floating in the air. It moved up. Now we are in your OneNote journal. So far, we have learned a little bit about computer programs, algorithms, and how robots use them to complete tasks. Now we are going to look at something called pseudocode, which is the pre-writing process for computer programs that just looks like regular everyday words. We use regular English. On the left, we have an image of this maze that we want to solve. We want to get this little yellow guy all the way to the finish line at this red pin. Let's look at different examples. We start with pseudocode. Pseudocode allows us just to say in English what step-by-step instructions we want that little guy to follow. For example, we want the little guy to go forward, then we want him to turn left, go forward again, turn right, go forward again, and then he gets to the end. By following these instructions from start to end, our little guy gets all the way to the finish line. And notice we just used English for this. No fancy code, no complicated instructions. Then, when we move on to something like Microbit or Blockly or Scratch, we're going to use a block programming language. This allows us to take our pseudocode and put it into actual instructions our computer programs can follow. Notice it's the same instructions, except now it's in an actual block language. Once we have this simple pseudocode in plain English, we can translate that to our actual programming language, like Scratch or Microbit, or even something like Java when we learn how to actually write code. All right, now it's your turn to write some pseudocode. This guy here in blue is our Horizon bot. He is a robot that needs to pick up packages and deliver them all the way to our ship over here, the New Horizon, before we set off on our ocean voyage. These orange boxes on our map are the boxes that Horizon Bot needs to pick up and deliver to the ship. You will be navigating Horizon Bot through this maze to pick up the heavy boxes and bring them to the ship using pseudocode. Here are the rules. Horizon Bot should touch each box at least once. You should stay on the gray sidewalk and don't cross over the thick black lines into the red buildings. After you touch each box at least once, navigate to the brown pier where the New Horizon is docked and touch the New Horizon boat to complete the maze. You can use the following pseudocode terms: start, move forward, turn right, turn left, and end. Write your pseudocode here. After you have written your pseudocode and done the optional challenge, ask yourself, did you design the most efficient algorithm possible? Share it with a partner. See if you guys can come up with another way to navigate with as few steps as possible. Once you have written your pseudocode, congratulations, you have practiced writing your first computer algorithm. You've completed lesson 2. We'll come back for lesson 3.